Hello everyone. I thought I would record a quick video showing how to set up a heat loss design for a property such as a barn conversion, a stately home, anything that kind of has these thicker wall sizes that make it a little bit more difficult for h2x to pick up them as being internal, and just some of the more kind of outline design scenarios in general. Okay, so let's jump right into it. Rather than us going through like the whole PDF upload process and everything in this video, we're just going to jump straight into the heat loss room drawing. You can find out how to upload PDFs, obviously how to go through your system settings in other videos, and yeah, we're just going to jump straight into this one. So if I zoom right in, floor plan there, we can begin to add our heat loss rooms. So first thing we're going to want to do is go into the settings. I know I mentioned that we weren't going to go through the settings in detail, but the one thing I am going to do is I'm going to set my wall widths to be something smaller, just around 50 mil, so that I can basically see the points that I'm drawing a little bit more clearly. And I'm going to set some clear colour differences between my internals and my externals. So my internals I'm going to have as green, and my externals I'm going to have as red. Just set those to there like that. Make sure you click on the colour and then click on the colour palette there as well. And then party walls will leave as grey. So yeah, let's go back into the project. First one I'm going to draw is going to be in one corner of the building on one side. The best way to draw rooms in h2x is to work from one side to the other, as this makes snapping a little bit more accurate and it results in less mistakes that you'll then have to go and redo. So if we go onto this toilet first, we can grab a cloak/WC. We can go to the inside of the walls marked on the plan. For this little alcove here for the window, we'll just hit shift and draw to the inside of the walls marked on the plan as before. Obviously the room's going to take the height from your default settings. We can also include this small storage area here if we wanted to, and make our way around the room like this. Just wait for the plan to load back in really quickly. Make that square, hit escape, and that's our cloakroom drawn for us. Okay, because these walls are thinner, we will be able to have these recognised automatically as internal. However, this bit of a thicker space here might have a bit of a harder time doing that. So if I click onto that, we can override the wall type and make that to be internal. We'll set the neighbouring space temperature to be whatever it might be, or whatever you're going to design to, so 18 degrees. And we're going to want to make sure that we do that on both sides of that wall. Okay, so if I go and add the study now, before I do that, I'm just going to reduce this results view to make it a little bit more clearer for you guys, just in case you want to have a look at the results as we're going. Okay, so if I go now and I grab a study, we'll start here, closest to the room we started with. We'll just make our way around the study. Similar to the way we did with the bathroom. Got a couple of windows here, and we have got a small alcove there. You could go ahead and add those 2 points, but for the sake of it, I'm just going to go straight past. And I'm going to include these two small pieces here, so just hit, I don't have to hit shift this time because it's square, we just need to go and add those points. I'm clicking in the scroller button on my mouse to pan. If you're working with a trackpad, which I don't recommend doing, I do recommend using a mouse, you'll be able to do that by swiping 2 fingers and it'll take you in the direction you want to go. I'll just wait for the plan to load in and we will get this doorway in as well. Click there, click here, and a click here, and make our way around that room. Hopefully we can just make it square. Might have to use shift because the wall isn't quite on a straight angle, so we can just get it exactly to where it's marked on the plan. Hit escape once we've got that last point in, and you can see there it's automatically recognised that wall as being internal. This small part of the wall here we need to override and make it internal again, and then just override the neighbouring space temperature to be that of the adjacent room. Okay, so that is the study added. Going on to the dining area and the living area here, you can see there actually isn't any closing off between these two areas. So I would mark this all as one space, and I would actually include this wall within the room volume. I'll show you how to do that now. So go to rooms, I'd go for a living, or I would go for a kitchen, depending, oh sorry, it is just a living room. Could argue that the kitchen is involved as well, however, you could just put a walk-through space here as well by putting a door in there and just saying that that's an open door, because the temperature differential between the two rooms won't be too much and it won't affect your heat loss calculations as much, whereas the kitchen will have a higher change rate. It just depends on whether you want that to be applied to the living room area as well, but I'll leave that down to you as the designer. So if we're going to do the living room and the dining area together, we'll just go and we'll add a living room. Start off by adding our wall points, using shift to add in these windows as well. Remember, we can let go of shift when we're just doing straight walls on, say, like your 90 or your 180 degree lines. I'm going to cut it short around here, just lining up with this room here. So if I do, with that wall face, sorry, I just do that and go across to there. Add that as part of the living room. And I'm actually going around all of these sticking out pieces of wall. However, if you wanted to, you could just go straight down, which is what I'm going to do for the side of the building. Actually, I'm just going to go straight down. I'm not going to include the alcove for the window. That would obviously be down to you as the designer. If you were to carry these calculations out manually, I would just do whatever you would do in that scenario, i.e. whether you would account for, say, this stretch of wall here, and this one here, and this one here, or whether you would take it as just one wall face. Hit escape. And then again, you can see that these walls have automatically, well, this is automatically recognised as being internal. We just need to set these as being internal. If I hold control, I can do this in bulk. Set them all to be internal by clicking override, internal wall, set the neighbouring space temperature of whatever they might be. It might be that one side is colder than the other and you have to do one set first and then the other, but let's say they're all 18. I've set that up to reflect that. Now, you may find a situation where you miss out a part of a room, which I have done for this cloakroom here, and I'm going to include this cloakroom area as being part of the living room. It is possible to edit your rooms once you have drawn them, so for any corner that you want to add, you need to add 2 of these wall points. So we're going to want to add one here, where we're going to cut back down, and then we're going to want to add another one in the centre here. can then align that to that point. We may need to add another one as well here. So if we add a wall point, because we have got a little bit of a corner to go to there, to there, and then we just want to add one more to here. And I'm holding control to be able to move these points individually. Every time I move one, it remains on my palette. So if I go and hit another one, it'll move those together if I hold control. If you don't want that to happen, you have to click away to open space. So it may be a case of zooming out, clicking away to clear the palette so that window menu's gone, and then you'll be able to override, well, move those points individually. But you can see there, I've now done the study, the cloakroom, and this living space. I'm just going to pause the video and do the rest of this space up here. Now, it is important to note that we did have these two spaces separated due to the kitchen having a higher air change rate, and I was wanting to separate off those areas so we don't have the extended heat losses through the living room and the dining room space. What we're going to want to do is we're going to want to make sure that we get this alcove or the open area for the set of steps there as close as possible, or to reflect the internal wall or whatever it would be. We then just need to add on a doorway, single doorway like that will do, and set that at the size of that space. So probably around 1600 mil from 1.6, and then set a U value to either reflect kind of an open space, so like a super high U value, or you could just leave it as what it is, and then just take it that the room design temperatures aren't that different, so you won't have many losses accounted for through that forever space. Okay, just make sure with these instances that these walls are overridden to the adjacent room design temperature by clicking on them, also under control, internal wall, 18 degrees. And then where you have a split in the wall like this, use a wall point to say that that wall is external for the right side, and on this left side it's actually internal. So we'll just click onto those. Remember to click away first to make sure the palette's clear, because if you have say a door selected or a point selected and you select some walls, it won't give you the option to edit the walls together because they're not the same entity. And that is how you model that kind of space. Okay, I'll pause this video, and the next kind of hard part, or the next unique part, I will unpause the video and let you know what I do. Okay, so we've pretty much got all of the rooms modelled. We've managed to override the external wall, well, the external walls that have been recognised on the internals. By just clicking on them, setting the neighbouring space temperature, and adding the wall points for wherever they obviously change, if one part of the wall is external or not. Another scenario you might come across is where you have a garage or something like that, like an internal unheated space. What you can use for this is you can either go ahead and set the wall to be internal and do something like 10 degrees to reflect the unheated internal space, or you could actually use the party wall. The party wall will take into account the adjacent winter temperature in the settings, and this is used for things like terraced houses, for obviously temperature on the other side of the party wall, or for apartments or anything like that. Okay, so with this, we've now got our heat loss completed. I'm guessing that looking at some of these values, you're thinking, oh, a barn conversion? No way, that's a little bit too low for those kind of materials and everything like that. 6 kilowatts isn't really realistic for that size of property. So that would be a case of going into system settings, setting the external wall materials and things like that, which you can also change on an individual basis. So say if we put it to solid stone, internals we'll go for solid brick, party walls we'll still have the solid stone, and then windows Could leave everything else the same as if we'll be refitting with new windows and things if it is a barn conversion. Going back in, you can see that that's now put us up to around 15 kilowatts. And what we also need to do is reflect the heating air change rate standard that they're choosing. So I wouldn't say it was post 2000, I'd probably say it was pre 2000. And then, yeah, around 16 kilowatts for that size property. Obviously, we still need to add like the windows and doors and different things like that. But this, hopefully, this has given you a good idea of how to model this kind of heat loss. Yeah, let me know if you have any questions. Thank you very much.